for the recorder. We will begin in a few minutes. Yeah, don't please avoid using built-in functions. I know there's a lot of built-in functions that make your life convenient. The point of this exercise is think recursively, because you have to do that for your assignment, and you have to do that for your exam. Okay, my department head call, so let me pick this up real quick. I'll be right back. All right. So let's begin. Video is recorded. Okay, so today I'm going to continue on with functional programming. The topic that we're going to try to basically focus today is dealing with data. How do we manage data? What are the assumptions that we are going to make for the data? Before we go into those kind of topics, let me briefly recap what we learned last week, because this semester the class schedule is a little bit weird. It's 4 hours per week, but it's entire 4 hours. So you might have forgot what we learned already. We talk about functional language, and then we basically make an argument for functional language where when you write a program, it's basically applying a bunch of functions together. These functions are essentially, if you think what is it's a math function, right? So if you are in my architecture class, or if you are learning like something from the hardware, you know that eventually every single piece of your program becomes a data, 1 or 0, right? Those are numbers. Numbers can form and create a new set of numbers using functions. So using that assumption, basically, you can create a program by applying a bunch of functions, right? The basic ones would be and, or. The more complex one can be things like factorial. The even more complex one would be something like TensorFlow concatenate, for example, right? These function definitions basically are trees of expression, right? Whatever you write on that line, we call that expression. Function definitions are basically expression bundled together to form a new expression. And eventually these so function will, at the end of the day, you're gonna get some value. And we treat it in functional language, we treat function as a first class citizen. right? And in here, instead of using a loop, we use recursion. Essentially, what is recursion? It's a function that calls itself again and again and again and again, right? So in some way, this is like calling the next iteration. So you can write something like this. A function name, input types, right, with multiple inputs, and some return type. Inside the bracket, you write your own function. The return type is optional unless the function is recursive. Why? Basically, you need to know the type, otherwise you can't call the next function. And we talk about compound data, right? Compound data basically extend the single data items into a collection of items, right? The first compound data we talk about is tuple. What is a tuple? Tuple is a collection of items. A pair is one possible form of tuple, right? It has two items in this case. A tuple in general can have any fixed number of items. Keyword is fixed, right? You know exactly how many items you are going to have in the tuple. So some example like hello and one means that it's going to be a pair of string and int, right? And then we talk about list, where it's a collection of items and you can always add things to the list. In Scala, it's a front access list, which means that if you're adding something or you're accessing something, it's accessed from the front. So you can make a list using just declare list in parentheses, whatever you want to add in the list. And you can stick the elements to the front of the list. You can access front of the list. And you can use the double colon here, right? Let me highlight a little bit here. I need my pen. I'm gonna type. Okay, that's the option. This double colon specifies that I'm gonna concatenate these elements into the front of my list. And we talk about pattern matching, which think about it as this is almost like a switch case in C or in Java, where it tries to map your variable to certain inputs, right? Certain form, certain pattern of inputs. And you get a warning if you're missing any cases or you have duplicate cases, because it means the program will be like, okay, I have no idea what I'm doing here. And these are the example. We went over this last week, so I'm not gonna go through the example again. And then we talk about options. What is an option? Option is basically it's a type that has two things in there. It can be none, which express nothingness, emptiness, or sum of type, which means that you have the value v of type t. And we talk about tail recursion. That's basically kind of like where we left off last week, right? So the difference between a normal recursion and tail recursion is, first of all, the last line of the function is a function to our helper function, right? This is the tail call. And the benefit is you would shrink the stack frame, and then you have this accumulator that would be slowly accumulate results. So toward the end of your tail call, you're done. You just return accumulator, right? And today, any questions about anything we covered for, last week before we move on to mutability? All right, I assume there's no question. If there's questions, feel free to type it in. I'm gonna look at the chat. If something come up, I'm gonna address those. So the next thing we're going to talk about is called mutability. How many of you heard about mutable versus immutable data type? Silent, assume that's no. Yes, okay, yes, it's good. No is also equally good. It means that whatever I say would be a new thing you learn. So let's look at the programming language first. Before we go to immutability, let's look at a component. Like what are the things that you need to have in a programming language? So you have to have a syntax, right? Similar to a normal language, you need the syntax. Something is not muting. So can you, unless you're asking something, please mute yourself. Okay, I muted everyone now. Yeah, so you can unmute your microphone if you're asking something, but if you're not asking something, please try to mute so that your background noise doesn't come into the classroom. So the first component of the programming language is syntax, right? And we talk a little bit about this. If you look at the language, syntax means the grammar, right? Do I have the correct subject-verb agreements? Do I use the correct articles? Do I use the correct like subject, verb, object? I don't accidentally do something like subject followed by object followed by verb, because then no one would know what you're talking about. So these are syntax. Then the next component of PR is semantics. If you look at the program, do you know what it means? What are the rules of the evaluation? If I look at my paragraph, what does the paragraph actually try to convey? So those are the semantic information. Idioms, right? The pattern is used in the language that express computation. Okay? A plus B, something like that, right? So you can see some parallel between programming language and human language, actually. Libraries are facility that the language provide, right? Basically, think of it this way. Libraries, these are you using it to call a complex function, a complex operation, right? How do I handle the I/O? How many people actually think about when you have to access the disk, right, the hard drive? Think about it this way. If you really, really want to access the files, what do you have to control? In the hard drive, you have this magnetic drive, right? The circular thing, if you somehow break your hard drive, you go crazy and you like hammer the hard drive, your hard drive, you see this circular disk. And then there's a pin that go and read value, right? On the disk. Something like this. And sorry about my super poor like artistic skill. It looks really bad here, but hopefully you got the picture. Somehow we have to yes. Somehow we need to actually from our driver, right? You need to actually know exactly where do you want to start reading and where do you want to stop reading, right? Have anyone think about it that way? Basically, you buy a hard drive. Some program is responsible for that control, telling, hey, go to that sector, that region of your disk and read it. Right? Basically, these are what the library provides. Right? When you write a program, when you use a file in C, what do you do? What do you do in C? Remember your old friend fopen, right? And then f scanf, f printf, right? And f close. Those library talk to the file system. File system maintain all the location of your files. It maintains how do you actually access the files, and that again is the library to actually access your disk, right? So these are the features of your program, and if you want to make your program easy to use, actually many programs provide a lot of libraries. Even some of you asked me already, can I use some built-in function? And I say, no, because I want you to practice using recursion. Basically, these are facilities that the language provides to make your life better, right? Tools, what is provided to make your job easier, right? What's the difference? So can someone tell me what would be the difference between libraries and tools? You can modify, yes. Well, I think you can modify a library as well if you want to hack the API. The difference is library is tied to the program you're building. Tool is tools are tools that assist you as a programmer to do debugging. IDE, for example, is a tool. GC, when you write program in C, right? GDB is a tool. allows you to debug code in C language, right? The REPL interface in Python and in Scala, those allow you to type one line at a time and you see the results, right? So these are two. The way I would phrase it, I guess it's more like this is more external to the program and it's more involved with how you program as a programmer. So one more thing about the property, it's not a property of a programming language, but each data type in the programming language has to specify whether the data is mutable or not mutable, right? At this point, you probably might have, when you play around with the list in Scala, you might have realized that whenever you append something, instead of modifying the old list, Scala actually creates you a new list. So you still have the old list and the new list that get created, a totally different copy, right? What does this mean? Let's say I map X to a value, something like list of 1, 2, 3, right? It means that the mapping between the name X and this list is forever. Nothing that I can do would change the map, right? It won't map X to a different list. And generally, when you build a compound type, right, and you access a piece of the compound data, we're not modifying it, right? There's no construct to mutate the data. You can add things to your list, and it will get you a new list that has this new item added to the list. But you can't just say, hey, I'm going to take the second item out, yay, and then the old list somehow has one fewer items. So can't you also change the mapping of it? Yes, you can redefine, which means that you use the same name on a different list. So it will be something like this. You have the object, right? Look at my hand, you have the object that X mapped to. And now you create a new object that X is now mapped to. So the two object is still somewhere in the universe. But then the name X is now pointing to the second object because you forcefully, as a programmer, map it to the second list. But the first list is still kind of like floating around inside the program. Okay, so what are the benefits of having immutable data? So these are basically what we call immutable data, right? You can modify the data. So you might ask, like, okay, it seems unconventional. Why can't I modify a piece of data? So let's look at the benefits. So if you somehow want to do a mathematical proof that your program is correct, you can guarantee, this is a nice thing about functional programming, because everything is a math function. You can then prove and guarantee no other piece of code can actually modify the content of my data, right? So if you know exactly, everything is now more well-defined. If you create something, create a list, it's there. No one else can modify it, right? So you can prove, if you want to prove something, you can guarantee that, hey, that list is not gonna get modified. So let's go through a few examples right here. If I want to sort a pair, right? You have P1 and P2, and if P1 is less than P2, you return the same pair because it's already sorted. Otherwise, you flip P2 and P1. What is the difference between the two sort pair? Can anyone will take a guess? What is the difference? What is the one difference between these two examples? The first one return the old pair, right? The old input pair. The second one generate a new pair. This is a totally new pair. It just happened to have the same value as P, but it's a new pair. Do you understand the difference between these two examples? Okay. Any question? How is that a new pair? That's a great question. Basically, when you have these brackets and the value inside is something is similar to when you declare, hey, I'm gonna create a pair that has 1 and 2 inside, right? You just take one value, you take the other value, and you say, hey, I'm gonna create this pair that consists of p.1 and p.2. This pair is different from p. You just take the value of p, you take the value, and you create a new one because you just say, hey, I'm gonna build a new one. If you want the old pair, you need to say this. You need to say p, so that gets mapped to the old pair, right? If the pair is, think about the one thing I want you to think about. If a pair is immutable, this is what I say, right? When I do p.1 and p.2, you get a new pair. If a pair is mutable, then the language itself has to define what 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 happened, right? The language itself has to define what happened. If it allows mutable data in the second case, right, then you need to kind of tell how would this behave. Do I get a new pair or is that the old pair? So that's a property of the language. You need to clearly define and tell the programmer, right? Because the worst thing the programmer can do here is misunderstood what is actually happening. So you need to clearly define. If it's mutable, this is what happened when I call this function. All right. So let's go to another example, right? You do concatenate. You concatenate two lists. You have fs and ys as an input. You generate the list at the end, right? If you are done with the xs, then you return ys, right? You return ys. Otherwise, you're gonna concatenate xs.head and appending with the concatenation of the rest of xs and ys. Recursion, basically. So let's assume that xs and ys is 1, 2, and 3, right? What would be the difference over here if we assume mutation is allowed and mutation is not allowed? Anyone want to take a guess if mutation is allowed versus mutation is not allowed? Like that. So one thing that can happen if mutation is allowed, and then one thing that I can specify in my language is I can say, hey, now ys, because I return ys over here, right? And then I keep appending the content of xs. So now yx is going to become list of 1, 2, 3, 4, and 5. Because I allow mutation, so now yx is gonna grow, get bigger, because I put the content of xs into ys. If mutation is not allowed, every time you do this, it's a new list, right? So xs over here in this case, xs is the same list of 1 and 2, right? Over here, xs is list of 1 and 2, ys is 3, 4, and 5, and then the return is basically 1, 2, 3, 4, 5. Any question here? Basically, if mutation is not allowed, ys is going to return the old list, and you return a new list that consists of 1, 2, 3, 4, and 5. All right, any questions? Okay. So, You can check out in class exercise 4. Basically, we want you to write a few functions here. It's already posted on Canvas, so I'm going to skip this part. We're going to do this around noon where we're done with all the lectures. Is that okay? Yes. Yes. So your question is, when we do the double colon on the list, you get a new list. Yes, that's correct. You get a new list. It's a totally, completely different list in Scala. Yeah. Anyone actually? Let me go sidetrack here. I think the next one is a different topic. Let me go sidetrack here. If you use C before, right? If you use C before, when you use a list, it means that you need to allocate a memory, right? Oh, if it's mutable, then it depends on how the language define it. It can potentially be the same list. In most cases, that's likely to be the same list, right? For example, a linked list in C, you got the same list, right? It's the same pointer to that list, and it just keep growing. That's in C language. But if it's immutable, you get a totally different list. Okay, so if your Scala is still not working, we should talk during the exercise part because I want to make sure it works. Okay. Yeah.
เวลา add annotation tail with มันช่วย compiler why do we need to add annotation
What do you mean by add notation tail?
you know like I read Star document นะเวลาเขาบอกว่าเขียน tail recursion you could add add annotation the add sign and write tail recur in front of the
Okay. Basically, the add sign, right? That say, hey, this is the tail recursion.
yeah that one
Okay.
yes
So that's a great side question that I would like to answer now. Actually, whenever you compile something, right? Whenever you write a code, say, hey, compiler, take this code and somehow make a great assembly file that would run really quickly. That is what you want to do, right? Hopefully, it generates a file that's fast. This annotation, we call this, sometimes we call it pragma. Sometimes we just say these are hints, right? It gives, basically, it gives the ability from the programmer to tell the compiler what is the property of that block of code that you are trying to compile. Because if you know, okay, that's recursion, there are certain optimization you can do in assembly. There are certain way you can write the assembly that there's certain ways you can optimize the code. There's certain way you can optimize the memory footprint based on the type of execution, like tail recursion versus for loop versus if else. Or something like you can annotate these data is all read only, then you can actually do a lot of optimization. OpenMP, which is one of the way you can write parallel programming, is also annotation-based thing. Basically, you use a pragma to say these for loop, you can parallel them, you can parallelize them. Each iteration can be done independently, so just run them on all the threads. So these are what the annotation are for. It gives the ability for both the runtime POS and the compiler to know more about the program. Right? Otherwise, you have to guess. So hopefully that will answer your question. Okay, cool. Yeah, basically, think about it this way. As a programmer, you can't directly talk to the compiler or talk to the OS, right? This is the way you can talk to the OS and say, hey, that's the data type. That's the block. The block supposed to do this and that. Don't let them guess. I mean, it's okay to let them guess, to be honest, these days, because the compiler is really, really good nowadays. But it's still better to give them hints. Another thing I want to say about immutability is whenever I generate, basically every time I append something to my list, right? As I said, I create a new list. So if I have to create a new list, one of the problems you might think about is like, okay, how about the memory footprint then? Because every time I generate a new list, do I need to keep track of every single list that I generated ever? Right? So if have anyone think about that problem? Because it seems like your questions are leading towards like, hey, but isn't that efficient? Because every time I have immutable data, I have a new list, right? So one way the runtime can figure out and optimize the memory is to just actually look at, are there any variable get mapped to that data? If there's no mapping, it means that no one else can actually map to that data anymore, right? So you can actually get rid of it. So the runtime actually are doing these days they're doing a pretty good job keeping track of everything. And if it realizes that data is not needed anymore, it free up that data. So I go super tangent from where we are supposed to go. Any questions? Any more questions about the immutability before we resume and talk about more data, basically records and pattern matching and how to deal with complex data? All right, assume that's a no. So one thing that we might want to do is we have the compound type, right? The compound type consists of multiple data bundled together. Can we generalize them, right? Yes, the answer is yes. There are actually, in the end, three types of the compound type. Product type, which we can say each of, right? The value would contain the predefined type. You know exactly what's the type of the value. Example of that are tuple, right? You know exactly how many things are going to go inside the tuple and what are the data types for each element in the tuple. That's also a sum type, something like an option, right? The value is there's only one value, but it can have many types. Option is one of that. Can have none or sum of t. Right? And recursive compound type is something that makes self-reference. So from what we use so far, what data type is of this recursive type? We talked about tuple already. We talked about some type of option already. So what's left that we already talked about? But yes, it is the list. Why is the list recursive type? Basically, it points to the rest of the list. It has an element that points to the rest of the list. So that's why it's a recursive type. A value of type T can refer to another value of type T. An example of that is the list. And you can have alias for the type. Basically, you can define this. If you want to make your program a little bit more clean, you can define alias for the type. Here's an example, right? You can say, I have a type person that consists of a string, a double, int, and a string. But this can be annoying, right? If you think about it this way, what is the first string? What is the last string? What is a double? What is an int, right? You need to remember what value should go into which pointer. For example, the first string might be your name, the last string might be your address. And then the double will be your height, the int is your weight. But then I can switch the height and weight, right? The height can go to the second as a double, or that can be a weight. So this can get annoying. The first, like in this example, if I want to have the second entry as a height, the third entry as a age, I can even come up with what should go in the last one, right? So record is designed to address this problem. Record is designed to address this problem. You can create, instead of a type of person, you create a class. In this case, we call it a record, a class of person where the first input is the name, the second input is height, the third input is age, and the fourth input is the address, and you specify the data type. These make a name record. You name this record person. And to use it, you can do this, right? You can just put in the correct order. If you know the order, you can say person John 18030 Thailand, right? And notice that in this case, you have to have the correct order. Or you can do this. You can say person height equal 1.8, address equal Thailand, age equal 30, and name equals John, right? These allow you to swap any order of the input. You forgot what's supposed to go into which position. Just say this value would map to these particular name. The value for height would go to the value that corresponds to the name height over here, right? And then you can bind. And you can bind using val. Right? Val would bind P1 to the first person. And you can then use the dot here to access the name, the sub variable, the internal variable inside the record. So what is this similar to? Let me ask you one thing. What is this really, really similar to something you might have seen before? Object in Java, yes. That's why if you look at different languages, right? C, Java, Scala, there will be some similarity. Why are there similarities? Basically, the good things that certain language invented or used and popularized, the other language would utilize it too. Right? Those are good things. So when you look at different languages, different programming languages, this is one thing you might have realized, but something I want to point out is there will be elements that have the same way you program. Why is that the case? It's a design decision that people say, hey, that's a good design. I'm gonna piggyback and use it in this language too. So to generalize the way you call a record, right? You can say it's reference by name versus reference by position. Right? So you can use the name or you can use the position inside the tuple to go to the correct value you're talking about. Let me go back here, right? Is this reference by name or reference by position? Reference by name or position? It's actually position. Why is that the position? Because you need to get the correct position. This is reference by name, right? Because you need to remember the name that you want to pair with. All right, so basically you can do it two ways, and different programming language can use either one or a hybrid approach. In Java, right? In Java, when you call a function, how do you call a function in Java? Can someone type me a random function calls? With at least some variable. Yeah, that's a legit function call, but can you have like some input variable? So you can do like something like this, like foo of x and y. Yeah. So you need to know what position x is going to. That's why we said caller. The caller use position. The callee, the function itself, the declaration. When you declare a function foo, what do? We do foo, right? Int of a and char, I guess, of b. Right? This is reference the callee use a variable name, right? So you can refer to a and b later. So in Python, this is a little bit more interesting. when you have a function call, there's a required input and there's optional input, right? In Python, you can have optional input to your function. Have you seen this before? So the optional input, you need to specify the name. Right? The optional input, you need to specify the name. The required input, you just put in the correct position. Right? So this is like a true hybrid approach where if it's optional, you need to specify what are you trying to assign, what name are you trying to assign that value to. But the rest that are required, you need to put it in the correct position. And one more thing before I think we would take a quick break is what we call syntactic sugar, right? What is sugar? It's a sweet thing, right? You put in food and hopefully the food tastes better, right? Syntactic sugar is something like if you see certain semantics the way you write certain program, and you say, hey, that's a really, really convoluted way to write the function. I want to make it easier to use. I want to wrap it into a wrapper function, into a different API calls to make it easier to use. For example, you can implement a tuple right, using record. Here, case class, my pair. Your pair. But then you can use tuple. Tuple is probably easier. You can just now call 1 and 1.0, right? That's it. You just create a pair. So you can say tuple syntactic sugar for record. The property of tuple is the same as this record I declared here, right? Basically, the syntax that are changed, that are make things that are easier to look at. It doesn't create a new meaning. It just repackage what is already exists to make it look nicer. That's why we call it syntactic sugar. Though you might or might not see this terminology, but the key concept is sometimes when your program is complicated or convoluted, or if certain things are hard to call, hard to use, you can make a wrapper function and make it easier to use. And then you can also create a sum type, right? So let's expand how we know sum type. The sum type we know so far is option. Okay, so let's expand this knowledge a little bit. Like, what if you want to create a possible arithmetic expression that involve addition and multiplication? How do we create that sum type? We can use the keyword trait. Oops, trait. EXPR is the name of the trait. Which can be any name that you want to define. And this thing is a keyword where you will say, okay, whatever comes after this is my trait. Expression, this basically means that our expression, what is a trait? Trait is how we can create a sum type. Sum type is a data type, right? Something like an option, right? So over here, let's create something like an option. What we do here, this definition means that my expression, EXPR, can take this class or this class or this class or this class. It would be one of these four. The first class is a constant that takes in a double. The second class is a negation that takes an expression and it negates the expression. The third class is called a sum. A sum takes in two expressions and hopefully that would add the two expressions together. And the product take in two expressions again as well, but now would multiply the two expressions together. And to ensure that you actually this class definition extend the correct trait, you just say extend and then the trait name over here. Basically, it means that I'm going to define a class called constant, a record, right? A class is a record called constant that takes a double as an input, and that extends the expression. Any questions about this? Okay, so over here, so let's reiterate, right? If you declare, this is the same thing, same example we have, but I highlight some of the important part. The expr that we just defined can be one of the following. It can be a constant with a value of n that has a type double. It can be a sum of two expressions. It can be a product of the two expressions. And more example is what if, oh, if you just reconnect, basically you can create a sum type using a keyword trait, and you can just extend the type that you want to have for that particular trait by using the keyword case something extend, and then it would extend that certain trait. Yeah, yes. So one more thing, one more example. Let's say you want to create a rank of playing cards, right? Well, what are all the ranks? You can have Jack, Queen, King, and Ace, right? And the number 2, 3, 4, 5, 6, 7, 8, 9, 10. That's a playing cards, right? I guess you can add Joker, and that's pretty much it, right? So you can do it this way. You can say trade rank, case, object. In the future class, we'll talk about what's the difference between object and a class. But over here, think of object this way. Object is that one and only. You can't create the new object from a class. I mean, you can create a new object from class, but you can't create a new object from an object. It just say, hey, there's an object called Jack, and it would be called Jack. It would extend the rank, can be clone object. You can create a name for an object that maps to an object. We'll actually let me put it this way. We'll discuss this in a little bit more detail about dealing with all like object-oriented programming concept in I think in about 3 lectures. It is a singleton. Yes, exactly. That is a singleton thing. Yes. Yeah, object is singleton. So class create object. Object is mapped to. No, an object is not mapped to object. You can create a name that maps to an object. You can define a name that you want to, whatever you want to name, that maps to an object. All right. So, but basically, this example would create the type rank, right? That can have four different objects: Jack, Queen, King, and Ace, or it can be a number. Both of them, not both of them, all 5 of these extend rank. Right? So whenever you refer to rank, it can take in one of these forms. It can be a Jack, it can be an Ace, or it can be 3, right? And that's your playing card. And notice we mix up both class and object in this. We'll discuss the object-oriented programming concept formally in functional programming in a few more lectures. All right. It's been about an hour, so should we take a break now or? Okay, so to answer your question first, so the question was like, now that we create this rank, right? How do we actually use it? how do we actually use it? So it's essentially, now that we create this, we are going to talk about how we use it right here. But let's take a break. Let's take a break right now, and let's meet again at 11:05. Is that okay? Okay, sure. So we'll continue, and basically I would answer your question. Uh, all right. So let's meet everyone 11:05. Get coffee. Get whatever to make you wake up, and see you in the bed. All right, are we all back? Okay. So there was a request to for me to go a little bit slower, so I'll do that. Sorry about going a little bit too fast earlier. If you still have questions after we cover all the content today, feel free to ask the questions you still have. I'm gonna go back to the corresponding slides to make sure you understand what's going on. All right. Okay, and we talk about, so earlier on, we talked about, okay, let's create a sum type, okay, using traits. And we have the example of how to create the expression for product and sum. How do we create a rank of cards, right? So how do we use it? The way we use it is pattern matching. Right. So if you remember our old friend pattern matching that we use for the option, right? Case none, do this. Case sum of something, do this. We can use the same trick, pattern matching, to match the sum type. So let's assume we have the expression here, right? Constant, negation, sum, and products. If we want to evaluate this expression, which can be constant, negation, sum, or product, we can do this. This is a pattern matching. Why can I tell that this is pattern matching? Look at this part, right? I have the keyword match. This is my input expression, right? This is the input to your function. Input E, right? To the function that is called eval. Right? So I have a function called eval. Take E, which is of what type? What is the type of E? Hey guys, wake up. How can I tell the type of E? E is actually expression type, right? Expression type right here. How can I tell that? It's right next to colon. What is colon? Colon tells me what's the type of that name. Right. So if E is of expression type, how did we define it? This is expression, right? It's a data type, right? As I said, it's a data type that can take in full form, constant, negate, sum, and product. So if I have E as an input, right, I would do pattern matching by say E match, E with the space bar and then match. What am I saying here is I'm gonna do pattern matching on E. If E is constant, what is the return value? Let's say I have a constant in my expression. What do I return? I just return that number, right? N here is a double, so you return N. You have a constant of type the name N, you return N. If it's of type negate, if E is type negate. What you do here is you can return the negative value, right? Negative value of eval of E. You will then evaluate that constant or sum or product, whether you evaluate that expression, but you negate them. If it's a sum or a product, then you would either add them together or multiply them together. These recursively evaluate, right? This is called to the same function again. But now, instead of when it's a sum, basically sum, it means that E is essentially E1 multiplied by E2, right? Why do we call eval? That's a great question. Because when you multiply the two numbers together, it doesn't guarantee that E1 and E2 are double. It just that E1 is expression, E2 is expression. If E1 and E2 are constant, then eval of E1 would give you N, right? You will get the result, the correct result anyway. So to be safe, basically you would recursively call eval on E1 and E2 to actually get the value. Because our assumption here is eval would lead to a value at the end. At the end of the day, eval would evaluate to certain value, right? So if you call eval of E1, it would evaluate to some value. Eval of E2 would evaluate to some value. So value multiplied by value is a value. What if E1 is double? So the other type that E1 can take is expression, right? If E1 is not double, it would go into one of these three cases. And because all the three cases would recursively call, so that eventually you break it down into an actual value. Does it answer the question? Basically, if E1 is not double, you go in there and you get matched to one of these three cases, right? And then you further break the expression down and further break it down until at the end of the day, you're gonna get a double. And from that point on, because it's recursion, you go back one level. If it's a sum, if it's a sum, you add the two numbers together, return the value. If it's a negation, then you negative that number, return the value. If it's a product, you multiply two values together, return the value. Which means that eventually you're going to get a value. Right? This is recursion plus pattern method. So let's say our expression, yeah, sure, I can show an example. Let's say our expression is 1 multiplied by 10. This is multiplied, plus 3 multiplied by 4. And this is, I guess, let's do it this way. And then over here you have negation. This is my expression. Let's say this is my expression, right? Eval on this, what's the first thing I'm gonna have? I'm gonna fall into this, right? This case, that's the first thing. Because it's a negation, that's the first thing I see. So basically, I'm gonna do, this is my value. It's gonna be negative, right? A negative of my expression. What's my expression? 1 multiplied by 10 plus 3 multiplied by 4, right? So this whole thing is E, and I have a negative value of that, let's say a negative value of E. Then I would eval E. Right now I do, let's say, let me call this E1. So basically now what I would do is eval E1. What will I max to? Eval E1. E1 is of sum type, right? So this is second step. Eval E1 is mapped to sum of, let's say this is E2 and this is E3, right? So basically this is sum of E2 and E3, right? Which means this is essentially eval, right, of E2 plus eval of E3, right? Are you still with me so far? Basically E1, which is a bigger expression, is a 1 multiplied by 10 plus 3 multiplied by 4. That breaks to a sum of E. And what is E2? E2 is a product, right? So this is basically product of 1 and 10 plus product, right, of 3 and 4. And 3 and 4, 1, 10, those are all constant, right? So last step here is our constant. So what is the product of 1 and 10? Is 1 multiplied by 10, right? Plus 3 multiplied by 4. We're going to get 10 plus 12, which is 22. And then this is E2, right? This is, oh, no, not E2. This is E1. So this whole thing is 20. The answer of this eval is negative 22. Does that example hopefully does it clear up this thing? Okay, perfect. So basically, that's why we have to recursively call eval, because eventually we want the value, right? So eventually everything will go into constant and it would recursively go back up. So you're gonna get the constant value back up. And as I said, expression in functional language, it's a tree, right? It's a tree of expression. Over here, the same thing, it's a tree of expression, and you're gonna get the value at the end. Though our second example, the first example is like you have expression and you want to evaluate it. The second example is, well, you have expression. What if I want to print it? Right? You want to print the expression. This is what I want to do. I have expression E, right, the same type, and instead of returning a value, I return a string. Right? At the end of the day, I want to be able to print that expression. So if you constant, just do n dot to string, right? The input to string, which basically means that I'm gonna get the string representation of that. If I have negation of E, well, basically you're gonna put negative and then stringify E, right? Stringify E. If it's a sum type, you stringify E1, stringify E2, and then have the add sign in the middle. If it's a product, then make sure you have this parenthesis, probably, right, to make it safe. And then have this multiply in the middle. So over here, if you go back to the old example, right, negative 1 multiplied by 10 plus 3 multiplied by 4. If you call this function, this is what you get. Negate of 1 multiplied by 10 plus 3 multiplied by 4. That's what you print out. Same example, instead of recursively eval, now you recursively stringify. Stringify, which would basically print what you're supposed to print based on the expression. If it's an add, print the plus sign. If it's a multiply, print the star sign. If it's a negate, print the negative sign. If it's a number, just print that number. So if you combine these two, right, example 1 and 2, I mean, you can think of it as an object, right? Object that behave like an expression. You can say this. You can say expression eval, right? Expression eval has two internal functions, 1 and 2, right? And then you put in the function name, and that's it. Now you have the object called xpr eval that can do two things. You can evaluate or you can stringify. Any questions so far? All right, so if there's no question, move on. one thing that if you use switch case in any other language, one thing that I haven't talked so far is the default case, right? What if you do pattern matching and you want to say default, do this. If it doesn't match to anything we specify so far, do this. That's simple. Use the underscore. Basically, you say case underscore, the code goes here. Okay, so that's a great. So the question, if we do stringify, we won't get an answer. Stringify gets you a string. Basic is a string that represents that. Yes, you would get a string that represents the expression that you want to deal with, right? Because you can't just say print e. Print e. If you do print e here, e is expression. What happened is then Scala would yell at you, I don't know how to print the expression. Stringify. So if you do print stringify e, then that would be okay because stringify e gives you a string and print a string is okay. So, all right, so let's go back to the default case. In pattern matching, if you want to make sure you don't forget any cases, use underscore, that's the default, code goes there. Any question about the default case, it's as simple as that. You can put it at the end, say case underscore. If it doesn't map to anything I list here, do this. All right, so what were the benefit of pattern matching? I kind of briefly talked about it earlier, I think in lecture 1. But generally, this is the benefit. You're going to make your code look less ugly, especially if you're working in groups, right, where your friends have to take your code and try to understand what are you trying to do here. It make it look less ugly and easier to understand. One really good thing is if you miss any cases that the variable can map to, the compiler will warn you if you miss anything, right? How many of you, when you compile your code and you look at the warning? How many of you seen the warning? If you use GCC and something.c and some warning pop up, how many of you seen the warning? All right. How many of you cares about the warning? How many of you sometimes don't care about the warning? Yeah. Me too. If I know what the warning is and I know exactly that's an okay warning, then I don't care. I ignore. But these warnings typically are useful because sometimes it leads to potential bugs, right? If I happen to convert an integer, a short integer, and it gives me a warning, that might be a potential bug if I need to use something longer than a short int, right? So with pattern matching, it would give you a warning that, hey, you might forget you haven't covered all the cases. It works for both option and list, right? It kind of like, how do you call it? It's pretty easy to work with, and it can be used on different data type, multiple compound data type. And yeah, whenever you see warning, as long as, well, okay, let me put it this way. Don't always ignore the warning. Don't always ignore the warning. If you're absolutely sure you're doing correct thing, then you might to make sure that, hey, does that warning mean anything? I know I do that too. When I program, when I need to submit my assignment, when I took a class, right? I ignore a lot of warning. But looking back, right now, let's say you have to program in real life, right, for someone, and if that program becomes critical, right? Let's say you have to program autopilot for a plane, right? One bug can kill the whole plane, like kill everyone on the plane. For that program, make sure you don't ignore any warning. Please, please, please be aware of that, right? when you actually are in a job, and if the program is critical, it can impact human life or impact like someone's well-being. Don't ignore the warning. It's there to make sure your code is absolutely correct. All right. Okay, so one more in-class exercise that in there, this is the last in-class exercise for today. We would like you to implement the following function: use recursion and use pattern matching. Is updated. Thanks Vicky for pointing out the bug here. I have updated the writing in the in-class exercise on Canvas. So check that out and basically go from there. All right. So that's not the first half, but like that's part of what we're gonna learn today. The next thing that we're gonna learn that related to the compound data is enumeration, right? And what is enumeration? How many of you use this thing in C or in other language? Have you used it before? Okay, in Python, that's also okay. It's the same thing basically. This is called. It stands for enumeration. So what do you use in Python? What's the purpose of enum? Yeah. So it's kind of you enumerate as the name suggests, right? It's something that you can enumerate. To actually define enum in Scala, you can use trait. The same thing as how you create a sum type. And here's an example, right? Now you see that we start using object, a singleton thing. A singleton object called north, south, east, and west. We would use the enum that's named direction. Right? A direction can be north, south, east, and west. Any question here? So this is how you can create enumeration in Scala. And this is the same as public enum direction north, south, east, west in Java. The exact same thing. The exact same thing. So with this, you can extract like we're basically with this and the concept of pattern matching that we have earlier, we can be fancy as I said. Pattern matching can be pretty versatile, right? So let's be fancy. What if you have the list and you want to extract the first two elements of the list? What can be the potential problem here? So what does enum do? This is a great question. So enum here is it allows you to enumerate and tell if you have an enum named direction, right? This limit the possibility of direction to only take for different objects. It can be north, south, east, and west, and not more. It allows the programmer to define what what does the enums like in here direction like what does direction what is the format of direction, what are the total possibility that direction can be, right? So oops, too fast. So what can be the problem if we want to do pattern matching and try to extract the first two elements of a list? So what if the list is empty, right? Or what if the list has only one item? It would work if your list has at least two items. So you can do complex pattern matching, something like this, right? You can start by assuming, right? Assuming that you have already two elements in the list, then you can do XS, right? This is the input. Pattern matching XS is the list. If it's matched to the part where you have two things in the front followed by underscore again, it can be anything afterward, which means that if it has two items over here is A, B, and empty. If it has three items is A, B, and C. You're gonna extract just A and B. and this would work, right? This return, this whole bracket, as I said, you see, whenever you see bracket, it means that the last thing in here is the return value. So A, because this return A and B, you map, right? A go into first, B go into second. So now FST would take the value A, SND takes the value B. Any questions about this example? Except for the part that it would fail if the list has less than 2 items. So another thing you can do in complex pattern matching is, oh, yeah, sure. So let me re-explain this. Basically, this is a simple case of, let me do this part. This is a simple example where if I assume that there are at least 2 items in my list and I say, hey, I don't want to extract one at a time because I know that I need the first 2 items. I don't care about writing. I don't want to write too many lines, right? Pattern matching so far, we would have case A colon colon the list. Like E colon colon X S dot tail, something like that, right? Over here, we do a more complex pattern matching that basically tell the program to do this. If my list has at least 2 items, assuming that's the case, I'm gonna get A and B as the first 2 items. Whatever come afterward, I don't care. And then I'm gonna return a pair of A and B. So A colon colon B colon colon will pattern match to a list that A maps to the first item, B maps to the second item, and what comes afterward is in that underscore, which I don't care. So does it answer your question? Okay. So that's one way you can do pattern matching. You can use if else. You can do case if n is greater than 100, print this. Case n if n is greater than 10, then print this. Otherwise, default, print small. Right? So you can have if else inside here as I highlight, right? Any questions? That's why I said pattern matching can be pretty versatile. So you can have a if else inside, you can actually map to multiple things. It doesn't have to be one item at a time. It doesn't have to be one type at a time. And if you notice this, you will notice that the warning can become useful now, right? Over here in the first case, it would warn you that, okay, what do you do if it doesn't map to this list that has less than 2 items? There will be a warning for that, right? So let's rewrite our function that looks for a minimum number in my list. And I have a list and I want to find a minimum number in the list. Remember this from, I think, the last lecture where we have better min that do pattern matching with options and everything, and also tail, I think tail, not tail recursion, but use the intermediate value. So let's rewrite that function. Basically, you have a list, you want to find a minimum number. We can do the following, right? Complex pattern matching. Why? You have XS as the list, right? This is our list. You do pattern matching. If the list is empty, return none. This is the same thing. But then if the list only have one, if the list only have one element, which is h colon colon new, that means that my list has only one element, you return sum of h. If the list has more than one item, h colon colon t, it means that there's a first item h and there's a tail list t. Then you do math.min, right? Between the minimum value between h and min of t dot get. Any question here about this piece of code? Why is it only 3 lines and we're done with finding the minimum? So can you be a little more specific about which part that you don't get? All of them, that's also fine. I just want to know what the scope of the explanation has to do. Okay. So this is the case where it's empty, right? So that's clear. This is where list has one item, which means that you basically return that thing. The last line is everything else, right? Everything else. If it has 2, 3, 4, 5, 6, 7, 8 items. What you need to return, because I specify here, I want to return an option of int. So the first thing that I need to return, I need to say it has to be sum of something. It has to be a sum of integer. So are you with me so far? That's why we have to have the sum. Then I know that there's definitely more than one item. That can be 2, 3, 4, 5, 6 items, right? So what I want to do, I have extract the head, and then I know T is the tail list, right? I know that T is the tail list, and then I know H is the first item in my list. So I'm going to compare, use math.min. Math.min will find the minimum between the two numbers. So I do math.min between h, which is already an integer, right? Over here, h is an integer. And t is a list, right? List of int. Right? T is a list of int. So when I do min of t dot get, min of t, is this recursion? Min is our function name. Basically, I'm going to recursively go on the tail list to find the minimum of this tail list. Why do I have to use dot get? Anyone remember what dot get do to an option? Extract it, yes. So basically, min t dot get, min t would return an int. To get an int, you do dot. So basically, this is comparing h, which is int, and the minimum number of the tail list, and then return an int, right? To get an option of int, you do sum of this number. Does it answer your question? Okay, perfect. So basically, this is how you can rewrite the min function with a more complex pattern matching, and this is done in 3 lines. Okay, let's move on from pattern matching into how can we have data types that are polymorphic. What does morph mean in English? It's shaping, yeah, shaping, right? So I know that many of you play Dota, and there's a character called Morphling. It's that thing. Basically, you can morph into anything. Polymorphic means that you can morph into different types, right? As the name suggests. So one thing that I would recommend many of you to do is a lot of the name that we invent as a computer scientist, it has an English root, right? So if you actually try to understand the meaning of the English word, it typically suggests what it's actually doing. Over here, polymorphic types means that I have a data type that can morph into different type of data type, right? So here's an example why you might want something like this. Let's let's say we have a list of integer at a position k, right? Can you write a function n that returns the kth element in the list where k starts from 0? This is a function. You go through a list, keep counting, right? Keep counting until k becomes 0. Means that that's the number that I want, right? This is the position. Let me change the variable name into something more meaningful. This is the position. I'm gonna go through my list until the position becomes 0. It means that okay, that's the one I want. And then this is where polymorphic types come in. And then let's say I do this for in class exercise. And then in my assignment, I say, okay, make this for a string, and then make this for double, and make this for I don't know, uh, logic, true false, like boolean. You then get annoying. Why do I have to ask you to copy and paste so many functions, and I just change the data type from list of int to list of string to list of double, right? Obviously, this will be annoying and point, right? But you have to do our homework. So it means that you have to actually implement this somehow, right? So to actually make a cleaner version of this and use polymorphic types, basically we would first declare. That I have a function called ends, right? The same function. It takes in a list of type A. Type A is some data type. In this parenthesis here, you just specify that this function, I'm going to declare that A is a polymorphic type. It can take in any type, integer, or character, string, whatever, right? And then apply the same function, right? Right body of the end. So over here, I replace A with T is the same thing. T stands for type, right? You can use any name that you want. A list, it will be a list of this type. This function, I just declare that there'll be a polymorphic type called T, and my list is going to be a list of T. A list of T. What's wrong here? There's one thing that's wrong here that I need to correct. Can you spot it? Quick hint, everything here is correct. Everything here is correct. K is an int, that's okay, because K is a position, right? The position in my list that I want to return. There's one thing that's actually not defined here. It's a typo, but can you spot the typo? A, right? What need to be changed here? So what do I return? I know it's a list of T. So what do I return? You need to return T. Yes. Basically over here we say that okay, and deal with the type T, which is polymorphic type. Our list is the T. Once we find it, it's going to return T. Some data type T. Why is that important? It means that whatever is in the list and whatever am I returning is the same type. It just said that it's the same type. I don't care what type it is, it has to be the same type. And this code would basically work on list of elements of any type T. Any questions so far? Okay. I should not have this. My bad. This was supposed to go to the other lecture, but because we have the two lectures in a week, so this is our in-class exercise. But we can use polymorphism. Our in-class exercise use a list of integer. It uses a list of integer. What if we use T for everything? This is kind of like what I'm talking about right now. We can use T for everything as long as we know, as long as the type eventually is well defined and is within the definition of, like, okay, let me put it this way. When you write a program and use the type T, as long as everything you write is consistent and the program, like the compiler that look at your code and try to get the assembly code eventually know what data type you're dealing with, that's okay. This is similar to when you declare something in Python, right? And then say I equal 1.0. What's the data type of I? Double, right? floating point double, something like that. In Python, what if you say j equal bracket of 1, 2, and 3? Then I mean it's an I think bracket is a list, right? It's a list of 1, 2, and 3. So eventually, if you can reason about it and know exactly what data type you're dealing with, yeah, you can keep using T. Over here, it didn't in this example, it specify strictly T, the type inside my list and the type I'm returning has to be the same thing, because it's list of T and you return T. If you want to return some other data type, then you can specify that too. You just have to be explicit. You have to tell the compiler this is what you're doing. So I hope that answers your question. What if you use T for everything? Yeah, that's possible. All right. So I kind of give the answer for our in-class exercise here, but let's go through them because we are gonna teach. Basically, we're gonna go over polymorphic class, right? Not polymorphic class. Sorry, I'm going too fast. Polymorphic type. Polymorphic type. Over here, I basically specify that there'll be two types I'm dealing with. Get me the pen, please. Enter option pen. I'm dealing with two types. There'll be type A and type B. There'll be type A and type B. Where the first list is type A, the second list is type B. You notice, right, if you want to combine the two lists together into a list of pair, then our resulting list, which is a list of pair, will be a list of A and B. Right? A and B. The type has to match. That's the important part. If you use polymorphic types, it has to be consistent and make sense. And then you would then do pattern matching. If X and Y is empty, you return empty list. Otherwise, you return a pair of X and Y and zip of X, S, and Y. And this is just to be safe. This should not happen. This would work on case class and case object as well. Basically, you can use polymorphic types on many things, like records, for example, or object. All right. So before we go into the fold operation, which is something different from what we talked so far, any okay. So folding is a concept of how you can accumulate. Let's say you have a list and you want to apply certain function to every element in the list, but you accumulate that result as well. That's called folding. So basically, folding is what if you want to iteratively apply an operation to all elements and have accumulated results. And here's the example, right? The example of folding is, let's say you have the initial state, some initial value. It's the initial value of my list. Initial value of my list. This is the function that performs folding. LST is my list. This is accumulate state. Accumulate state means that when I apply the function to the first element, I'm gonna accumulate it. Then I apply function to the second element, accumulate it. The function is, let's define the name do magic. It can be any function, basically. It can be any function. These whole 4 lines means that for everything in my list, right, for elements in my list. Let's say it's 1, 2, 3, and 4. Okay. For objects 1, 2, 3, and 4, I will start with the initial state. Then accumulate state is I would apply, right, the state itself, the function, and the element, and I'll return the accumulate state. So this can be done using, so a list, for example, has a built-in function called fold left. You can do xs.fold left, initial state, and the function call. These basically means that I will start from xs, the first element. I will apply the first element with the initial state. So let's say I have this list. So let's say this is our list. Do magic, just the add is our do magic. Okay, so there was a question about can you use for loop in scalar? Yes, but it's not really like a functional programming concept. But yes, you can use that in Scale. I think they built the support for a for loop. So let's go through this. This XS is 1, 2, 3, and 4. And let's say initial state is 10. Let's say initial state is 10. What XS.fold left 10 plus would do is essentially this. You start with 10. You then add, because that's our operation, you add 1 by 1. This is the first element. Right? What's the result of this? You get 11, right? You get 11. The fold left would then go from the first element here to the second element, which is 2. Apply the same function, which is add, right, again, and then add 2 to it. So this results in 13. Then we move on to the third element. Start with the return value, which is 13. You add them. What's third element? That's 3. So you're going to get 16. Then you're going to apply folding again on the last element. So you start 16, you plus 4, you get 20. So the result of fold left, 1, 2, 3, 4, 10 plus is 20. So you get the rough idea. Basically, you start from initial state. You start from the initial state. Then you apply the function to the first element. Basically, apply the function between the first element and the initial state. That become accumulate state. Go to the second element, apply the accumulate state you just returned to the second element. Fold right would go in the reverse direction. Fold left, start from the left. Fold right, start from the right. Depends on the operation, because sometimes function doesn't behave in the way that it's symmetric. So it depends on the direction you're going. So that's it for folding. Just be aware you can use fold. The naming again, a lot of things with the way we named it has a meaning from a real life, right? Folding, you basically fold things together. Each time you fold, you get rid of one element, right? You work on one element at a time, and you apply whatever you accumulate so far while you're folding. All right. So we are done talking about folding and polymorphic types. Should we take a quick break? Maybe 10 more minutes before we resume. Is do magic? Okay, no. Do magic is not a built-in function. It's basically any function. I regret using that name. Basically, it can be any function. Is do magic over here. This thing is any function that you define. Basically, you can define a function of your own and you do the coding. Does that answer your question? Okay. So, how many slides do I have left? Let me double check. Oh, just a little bit. You mean the slides? Okay, then how about this? Let's take a break until noon. I'll keep this slide on, right? And if you still have questions about it, we can go over them again after everyone can process what's folding. All right, so we'll do a quick 5 minute break, and we will be back. There's only I think 6, 7 more slides on collection, and then we'll be done today. But let's do a quick break here because folding is a little bit different from what we have been talking so far. All right, and feel free to type in the question. I'll go through them once we're back. I'm gonna go get some water. All right, so see you all at noon in 5 minutes. Okay, there's several interesting questions. So how we iterate folding is from left and right direction. Basically, we start from the elements that specify the leftmost or rightmost. We start from there, and the do magic is basically the function that we want to apply. And the function doesn't have to be just addition. It could be a function that do x multiplied by y and then the whole thing squared. You can define your own function. We haven't talked about how we would define a function and use it everywhere yet. That's coming up really soon. And that's the part where I say function is a first class citizen. But over here, you can define an actual function that represents the application of one element to another. And for the other question that say, okay, how does it iterate for something other than a list? Depends on how. So for left over here is a library call. It's actually a built-in function of a list. So you have to see how it's defined for a different data type. Basically, if a collection that are not a list, they would specify what's the behavior. But when you say folding, most of the time it's the same thing. You start from the first element, then you iterate over, applying the same function over and over and over again for all the elements, and you accumulate the result. And over here, do magic is a function essentially. Hopefully that is clearer now, I guess. So it can be like factorial, for example. You can write your own factorial function and let's name it fact. You over here just replace do magic with fact. Or Fibonacci, for example, right? So you can replace that with another function. All right, so let's move on. If there's no more question about folding, the next thing I want to go over is a concept called collection, right? No, not collection. Exception. Actually, not collection. This should be exception. Okay, yes. My bad. Wow. Sorry. We are going to talk about exception. And what are exception? How many of you have never seen exception? I think I should ask it that way. I assume by this point most people seen exception so far. It actually come up the most often when you start to program for the first time because exception is something that happens when something goes wrong with your program. For example, what if you say, I want to evaluate 2 divided by 0? What happened here? It's undefined, right? So basically, exception is when the program want to yell at you and saying something is wrong. Right? Something is wrong. It's a built-in feature of a language to handle these issues. I will use the same example here again. How many of you sick of segfault? That's a built-in feature of the runtime to tell you something is wrong with how you use the memory, right? Over here, exception is essentially it's the built-in features of the language to handle the case where the program has no idea what am I supposed to do. And in Scala, you can use the throw keyword. You can say throw, similar to Java, right? So I think most language will use the word throw to throw an exception. So how many of you have seen the throwing exception in Java, Python, or other like those 2 languages before? something like this: throw new illegal argument exception, right? So it basically means that, hey, I have an illegal argument, something is wrong, deal with it. In functional programming, exception has a type, right? So because functional programming in general, including Scala, it's a strongly typed functional language. So it means that exception also results in the type. For example, let's say I have this runtime exception, right? XS can be empty because over here we want to be able to throw the exception for the empty list. In this case, the exception would be correctly typed as the list of integer if XS is a list of int. Why? Over here in functional language, the object that caused the exception, which in this case is the list of ints, will be the type of an exception. Basically, it goes to the same type as an object that caused the exception. Right, over here. Any questions so far? Basically, the type of an exception is going to be the same as the object that caused that exception. The second thing is, what do we do? Okay. So what do you usually do when you see an exception in Java or Python? Stack Overflow. Yes, that's one way you can do it. I guess cry and check Stack Overflow. That's one option, right? Trying to figure out what's going on to debug your code. What else? Give up. Yes, that's another thing you can do. Actually that's a valid thing to do. Give up. Pray. Yes. Ignore it. So I would group give up, pray, and ignore it as the same category as I'm gonna ignore. Right? I'm gonna ignore the exception. Why is it okay sometimes to ignore the exception? Well, when you ignore this, when exception occurs, the program terminates itself, right? Unless this is the program still in development, right? You're still trying to develop this program, you haven't launched it yet, right? And some exception that occurs, you know that, hey, I haven't figured out what to do in that case yet. I haven't figured out what to do in that case yet, right? So it's actually okay to ignore because it will come up when you actually have to handle that, right? So force you would force the program to terminate, which means that your program would never see the light of day. You can't sell it to your client. You need to eventually come and fix it. But at the moment, because you haven't figured out what to do with that yet, you can ignore them and pray that someone would fix it, or give up and throw it to your friend and hopefully your friend fix it. The second option is catch and handle that, right? How many of you used try catch before? In Java. So in Scala, same thing, try catch. So you can catch and handle that. So over here, for example, right, you have a divide by 0. Let's say you have a divide by 0. What you can do is first say try to do x divided by y and x modulo y. And then if there's an arithmetic exception, you catch it. Basically, you say catch, right? Catch, and then case E is the exception. Basically, in the case that you have the exception called arithmetic exception. I think I spelled arithmetic wrong. But yeah, if I have arithmetic exception, then you're gonna return 0 and 0, pair of 0, 0. You say, hey, I have to divide by 0, and return 0. You heard that's very costly, and that is true. It can be costly. Depending on, let me put it this way, the way the program flow, right? Whenever you have exception, let's say the program keep running. Exception pause the program. Someone has to handle that. The handling part can be done. It doesn't guarantee that the handling part will be done right away. So if you still try catch, right, and exception actually happen, there are quite a lot of things you have to do in hardware to support it. If you're curious about that, take the ComArch class. We'll actually talk about this. What happened when there's an exception? So we need about like one class worth of time to talk about why is that costly in terms of hardware, and why is that costly in terms of the runtime. But it's not like overly costly. It's not too bad. Assuming exception happen really infrequently, right? When you write a program, you want to make sure your program doesn't run into exception every function call. Right? Hopefully you don't do that. In most cases, there's no exception, so there's no cost involved. But you can catch and handle the exception. All right, so everyone with me so far? This is similar to how you do it in Java, right? And other use of exception. So let's consider something like this. I want to basically, I have a list of int, right? And I want to find the last item. And the last item I'm going to return it as an option of int, right? And I do pattern matching over here. If I found it, yay, I found it. I return that location, right? This look okay, right? Basically, you iterate through your list. If you find, so over here, key is what you want to search. What you want to search. And let's say your list is something like this: 1, 2, 4, 2, 6, 2, 8. And your key is 2. Over here, you want this last 2. Basically, this is what this function is doing. There can be many elements that contains the value of 2. And let's say your key is 2, you're gonna return that last item. So what you do here is you do pattern matching. If you found the tail, right? Basically, over here for this function, you have to keep going to find the last one. You can't stop until you are at the end of your list, because there's no guarantee that there'll be no more 2s until the end of your list. Any questions about this code? This is a recursive function, right? So one thing that you can use exception over here is, let's say I want to, this is almost the same example. It's 1, 2, 3, 2, 4, 2, 5, right? And you want to find 2. So basically you want to return this one at the end. This is going to be a long chain call. So we can use exception to jump out of all this deep function call. Okay. The next line, the next page will be the code. So any questions so far? I'm going to show the code. So this is basically what we are trying to do. Instead of doing this function call, right? This is recursively a bunch of function call. Typically, once you're done, you're gonna have to return back over here to the first function call. But over here for this particular function, this result is known right here, right? I know the result right here. So instead of going back this way, you say, hey, I'm going to throw exception to kill off this stack in my runtime and say, hey, I'm done. This is the result. So you can do it this way. Everything here is almost the same, except try and catch right here. Right? Try and catch. Why? When you found the key, you're gonna throw the location and say, hey, I found it. And then if you happen to find the location, you catch the exception. So this is throwing the exception. Basically, hey, I find that last item. I find that last two in my list. I'm gonna throw the exception along with the location. Over here, our recursive function would iteratively call this recursively, but whenever I see exception, I'm gonna catch it. And I'm gonna return this location. So this, instead of having function call like this, and then you return, right? You make a shortcut saying, here I found the location, right? And then you say, okay, I'm gonna throw exception. And you catch it. So does that, any question about this example? On basically terminate early. I have all this function called the call chain that's been running because we find it. We have the result already. We just throw the exception and someone please catch it. So that's kind of like a side purpose of the exception. But remember this. Most of the time, you would use exception to catch some rare cases of programs that behave weirdly so that you can catch and handle that. Or you can ignore that so that you know that, hey, this exception exists and you have to somehow ignore it. Had ignored and you have to somehow eventually figure out what to do with it. All right. So that's it for the class today. It's about the time I planned the lecture to be, roughly 2 hours with the break in the middle. We'll switch over to the in-class exercise 4 and 5. But before we leave today, we talk about collection a little bit, right? And we want to say, one more thing I want to say, this collection that comes with the library method in Scalar can be pretty versatile, right? So let's assume you have a list now. You can do out.length to get the length of the list. You can use access with some value to check if this whatever value exists in the list. You can map. We'll talk about map in a bit. This is a parallel primitive. So once we move on to parallel programming, map will play a really big role. You can filter out elements. This is also parallel primitive. You can make this run in parallel. So that will play a big role again in parallel programming. And you can add a bunch of items in the list using sum, right? So these collection, the list is a collection. This can be pretty versatile because there's a lot of built-in library. You can drop elements. And if you want to figure out what else can you do, check out this thing called scalar doc. It's a document that tell, okay, if you have a list, these are different functions that you can call. If in the assignment, if I don't want you to use certain function calls, I'll tell you explicitly. In the in-class exercise, try to avoid using this because these are making your life way too easy. Assignment 1 is out. It's due in 2 weeks. As I said, if there are libraries that I don't want you to use, I would actually specify it in the assignment. If you don't see that, feel free to use whatever you want. But it's due in 2 weeks. Assignment 1 is out. It's due Friday midnight. On October whatever is the 14 days from now. October 9th. Thank you so much. Sorry. Yeah. October 9th at 11:59 p.m. And if you're done with the in-class exercise, feel free to check it out. It's also posted on Canvas. You can use the rest of the class slots. How many late tokens do we have? Please check lecture one because I actually forgot. Once I'm done with this slide, I'm gonna go check lecture one and I'll tell you. Right? Is that okay? Let's just wait a few more minutes. I'll tell you. And after I check lecture one. All right, so that's it. Basically, let's go move on to the in-class exercise. Do you want to keep using WebEx for a discussion or do you want to migrate to Discord? Both work for me. Is there a starter pack? Nope, you start from a blank file. Most of actually all the question is basically start from a blank file. Yes, we'll figure it out. Scalar is not working. So let's use Discord so that you can share the screen. Is it okay? So let's all of us migrate to Discord. We'll meet in to like 12:30. Let's meet in 12:30 and making sure everyone has Scalar working on their machine. How to submit Scalar code on you mean on Canvas? You can submit the file. You can copy and paste the code. For the assignment, please submit the file. You basically zip everything together. You can copy the code in a Notepad++ and save it as .scalar, I guess. I mean that works for me because whenever a student uses IntelliJ, it's pretty clear. It's pretty clear to me on how I would run it. So don't worry too much about that.